Hello.
Hello?
Sorry, I'm muted. Yes, can you hear me?
Yes.
Okay, I can hear you now. Tell me when you're ready, yeah?
Yeah. Mhm.
All right, you're ready. All right. Okay. So, Kirana, tell me, how are you right now?
Uh, okay.
Okay, you don't sound so bad. I mean, how's the fever and everything?
It went down already.
It went down. Glad to know. It's very fast that it went down. Uh, my son also is still having a fever, so hopefully, yeah, you seem better than him. Uh, 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 well, how's the competition then? How's the match?
I didn't go for the match.
Of course, of course. I mean, you have to rest, but do you know what happened? Like, you know what happened to the team, right?
No, not really.
Right, right. Maybe you'll find out tomorrow then. All right. Okay, sure, sure, sure. Um, Again, glad to know that you are feeling better. Now, if you feel a little bit weak today, you just tell me, okay? Right?
Mm,
If possible, we don't force yourself and then you're sick again. That's not a good idea, lah. Okay. All right. Now, updates please on, I guess, on the homework. Is the homework done or something?
like my March holiday homework.
Yep, yep, yep.
Uh, like one or two, then I finish.
Oh, okay. Do you want to talk about that now first?
Uh, I still have my uh bio worksheet to do.
Right, right. You mean the math and chem is done, like that's what you're saying.
Yeah.
Okay, okay, understand. Okay. Right. So today we have some freedom lah to study what we want. Now let's see our situation right now. E-math, you are basically already doing your self-study,
Yeah,
correct?
but I
By
need
doing the
to
homework lah, I
self-study
guess.
my math again.
Tell me why. Tell me why. Because
Because I don't understand anything.
wait, but you did your homework. So you did your homework, right? On 4.1
Yeah.
at least. Am I
But
correct?
because that was with my
But you
teacher's
didn't.
guidance on her video. But like I still don't understand.
Especially 4.2 then. You have to study
Wait, not
4.2 also.
E-math, E-math, E-math.
Yeah, no, AMAT, I'm not surprised lah. But EMAT,
E-math I
self-study done first lah.
understand.
Okay, good. So understand, do homework, and then we can say that, yeah, we're at least on par of the class lah, with the class lah, correct? For EMAT lah, for EMAT. Okay, yeah. EMAT clear, yeah? EMAT clear, yeah?
Mm,
Now, we have two options here. We have two options. Of course, it's AMAT or Chem lah, because your Chem, yeah, I understand also, actually your AMAT was doing better than your Chem lah, correct or not? Am I correct or not?
mm.
Right. So maybe today we spend one session on AMAT looking forward and the other session on Chem looking forward. Would that make sense? Would that help you, in your study next week lah?
Mm. Okay.
All right. All right. So you choose AMAT first or Chem first right now?
Uh, Chem.
Okay. But you're gonna tell me until when your topic is, until what, and then what are you going to study afterward? Just tell me roughly what first.
Uh, hmm. My chem topics is from the atomic structure, kinetic particle theory, and experimental chemistry.
Those are for the exam, right? Which is already done lah. Am I correct?
Yeah.
So atomic structure. So what's the next chapter, Lee? Just to confirm.
Chemical bonding.
Okay. So atomic structure and chemical bonding. Now, before we start anything, I want you to send me your WA1 chem working. Take a picture using WhatsApp, like, just send to me. Can you do that right now?
My working.
Right, because the exam, right? Actually, yeah, I
Like
need to
the
see all
exam
your exam.
paper.
Not just the question though, but
I
also
don't think I
your
have it
working lah,
because
your working.
my teacher collected the paper already.
So your E-math, A-math, and Chem don't have. Everything don't have.
My so you want E-math and A-math exam paper.
No, all the exam I want your working one. So getting used to it, like getting I really need to see your working in the exam. Then I also can tell, okay, really certain things happen, and I think certain things need to fix, yada yada, blah blah blah. Just like last year. Okay. Just remember that for next time. Certain school have a habit of collecting their students' paper and not returning it lah. Are your school like that one?
Yeah. I mean like the
Mm.
teacher will probably
Mhm.
collect for like the last week of the term, then we'll get it the next one.
So, for example, next week you will get them back, something like that.
Probably.
Okay. Now, once you get them back, please send pictures using WhatsApp. Your A-math,
Okay.
your E-math, your Chem. Basically, the subjects that we are actively studying in tuition, right? Once you do that, I will have a very good idea what's going on. All right? Okay.
Okay.
Okay. That's every time, yeah. That's it. Okay.
Yeah.
Now let's go to Chem. Then I will have to guess a little bit what's going on, but it should be about right. Please go to your Jamboard. Do you want to use a different Jamboard or the same Jamboard? That's up to you, but you tell me. Okay.
I think different.
Okay, sure thing. Uh, you tell me when you have. Oh, I need to make for you, isn't it? I need to make for you. Right.
Yeah.
Sorry. Okay, I'm gonna make something right now. Okay, I'm gonna type Kirana Cam, then 01 first, and then share it with you. Oh, Jamboard a bit slow. Yeah, Jamboard is already getting slower and slower. Right. Okay, I have shared with you. Okay, have shared. Right. Tell me if you cannot get me.
Okay.
Yeah, I think okay, right. Okay. So I'll tell you about the upcoming chapter. This is a you being a good student, we're studying ahead kind of thing. It will automatically talk about your atomic structure because the chemical bonding requires the atomic structure. All right. So you get a looking forward and a revision at the same time. Admittedly, chemistry, if you don't have study Admittedly, chemistry is slightly harder to study forward lah. It really depends on the quality of your teacher's note. All right, if you have them in first. So chemistry requires some help, but the good news is it doesn't take as long as math. For math, you can definitely study from the textbook, at least the E-math one, and then that will be enough lah. That will be enough to be a good student. I'm going to show you something. Yeah, I have enough. Okay, I'm going to rely on some video first because I realize I haven't given you the chemistry model. So there's something I owe you, which something I should give you in church. But now don't have yet. So you're going to see my video for a while. Okay, for a while.
Okay.
Yeah, you can see me, right?
Mm.
Let me do that for a while. So you don't worry about the Jamboard for now. This is something that you will have in your possession very, very soon. All right, but just not today. Orange guy, this orange guy has one hand, okay? Orange guy has one hand, right? Blue guy has two hands, which is different from the orange guy. And yeah? Okay,
Yeah.
and then dark blue guy. Dark blue guy has how many hands? Oh, sorry, not that. Dark blue. Okay, here you go. Here's a kind of purplish guy. Do you see how many hands does it have? See that? Sorry, so difficult to show. Right. Oh, so difficult to show. How many hands does this guy have? This is just so difficult. Okay, this guy have 1, 2, 3. I'm holding one of them. Okay, so 2 and 3, right? And then last one, there is this guy lah. Sorry, get that. Okay, this guy have 4 lah. Okay, I should not be. Okay, 4. So here's the rule. Here's the rule for this will be. I'm sorry. This will be hydrogen, and it will not be anything else anymore. Okay, so for some strange reason that you don't know yet, hydrogen is one-handed and it is orange in color. The color doesn't matter. Atoms don't have color. Yeah, atoms don't really have colors. How do I explain that? I can't explain that because you don't take physics. Okay, atoms don't really have colors, but atoms do have what you call handedness. I explain to you very soon. Hydrogen. Oxygen. Okay, oxygen is two-handed. The color is to help us simply identify. The important thing is the two-handedness. The color is just there to help us. The color will not affect the exam in whatsoever, but the handedness, the two-handedness is what we're chasing after using this. Okay, so one more time, what is this? Kirana?
Hydrogen.
And then this guy?
Oxygen.
All right, now let me ask you, what is this guy? Okay, this is just me, right? Here's your one-handedness, still the same. Connecting it, right, using this pipe. Oh, sorry. With another one. See, I'm just connecting them both. So now tell me, what is this guy?
Two hydrogen.
Two hydrogen, or more precisely, it is no longer two hydrogen. It is two very happy hydrogen. What do I mean? Here's the rule in the chemistry world, in the world of atoms and molecules. Believe me when I say this, this is the rule they live by. If there is even one hand free here, here's a one hand free, it's not connected to anybody. This is one-handed but connected to the other guy. This one is not. These two are very happy and contented hydrogen. And this is a very unhappy hydrogen. That's the rule. Whenever you have free hands, two free hands, they are not happy. They're very unhappy. One free hand, same thing one. Even worse lah, to some of them, right? So all the hands in the molecular world has to be holding something, so to speak. Can ya? So if this is one hydrogen, one very unhappy one, this is two hydrogen very happy and bonded, right? Which, please understand, has no room for this hydrogen. Do you understand? This
Yeah.
hydrogen, two very happy, no longer has the ability to hold the other hydrogen. They stay happy by themselves, so to speak, together, but not able to share their happiness or their contentedness with this guy. What must this guy do? Tell me. What must this guy do?
Mm,
What must this guy do? Find another unhappy hydrogen and bond.
oh,
Okay? Clear, yeah?
okay.
That is what he must do. And frankly speaking, if there is none, if in this whole world there is only three, two hydrogen, another hydrogen, two will be happy and one will not. That is how it works in the molecular work, and that's what you're going to study in the chemical bond chapter. A very foundational chapter. Totally must understand one. Cannot memorize one.
Mm,
Nothing much to memorize. Very important to understand. So I'm going to write this in the Jamboard right now. Okay, now you go to the Jamboard. Wow.
okay.
And wait, where's my pen? Okay, got it. Iya, halo, halo Cindy ya. Sorry, did your mom
Lagi.
call? Sorry.
Ya,
Oke, iya, yes, Cindy, ada apa? Ya, gimana?
Nggak apa-apa, cuman menyapa di hari Minggu aja.
Oh, hai.
Gue bisa ngeliat lo, tapi posisinya Kirana kan dihadapkan oleh seorang pria ya.
Jadi maksudnya gimana?
Iya, dia kan gue nggak bisa ngeliat lo. Gue bisa lihat lo, tapi gue nggak bisa
Oh,
karena dia kan menutup wajahnya
nggak bisa.
dengan K-pop.
Oh, begitu. Oh ya, nggak apa-apa. Video dia nggak on sih, BTW. I don't think so ya.
Iya, video dia nggak on emang, tapi aku bisa melihat
Mm-mm.
wajahmu memakai
Mm-mm.
kaos merah.
Mm-mm. Mm-mm.
Ya
Mm-mm.
udah nggak apa-apa,
Dan
Lip,
apa
cuman
namanya?
menyapa saja.
Oke. Hai. Okay. Right. Back to you, Kirana ya. Right. So in the Jamboard, you have H2. You do not say 2H. Of course, there are two H's, but they will immediately bond, form a relationship, make both of them happy. I will draw hydrogen. I draw H2 for you. This is the official way of drawing it lah. One hydrogen, another hydrogen. Okay. Let's just say that this electron belongs to this guy. This electron belongs to that guy. And in the bond that you saw just now, they are sharing it. So there are two ways to draw it, either like this or like that. This looks exactly how I would put it here. Right? Correct? There are no two
okay.
H's. There's H2. But if there is three H's, just to be clear, there is no such thing as H3 because how can that happen physically? It cannot happen. If there are three H's, it will just be H2 and, well, one H lah flying around, don't know where lah. Very unhappy. Very happy. Clear?
Yeah.
There is also no H4. There is none like that at all because it is physically impossible for four H's to bond. There will be two H2 and they are both happy. Do you understand what I'm saying?
Yeah.
Okay, now go back to the video. Tell me what this is.
Two happy oxygen.
Yeah, which you no longer call 2O. Do not call it 2O. There is now a special number at the bottom. Okay, we now call this O small 2 at the bottom. This is O2. You don't call it 2O because O2 implies that they have formed a bond and they're happy lah in that relationship. They're very happy. So in the Jamboard, I will draw O2 for you. 2, and then you have one O and one O. The overlap is to indicate the fact that they are sharing electrons. The two hands are imply the electron that is looking for a partner, and therefore in O2 you would notice that each share 2. He shares 2, he also share 2. You see that in my drawing there is an overlap at 4. 2 from the left, 2 from the right. Am I making any sense?
Yeah.
Okay. They will ask you to draw this one first. Okay, they will ask you to draw this one first to indicate your understanding. After a while, especially in year 4, they will do the shortcut version, which is this one. For now, first one. After a while, second one looks a lot like the model. Understand both and understand the fact that O2 now holds a special significance. It is no longer 2O. So same thing There is no such thing as 2O because they will form a bond. O by itself also cannot do anything, very unhappy. There is no such thing as O3. I'll technically say that first. There is only O2 and a very happy O2 and a very unhappy. There is no such thing as O4. There is 2O2. Would that be okay so far?
Yeah.
Now, I will show you the famous water chemical formula, H2O. So far, so good? I will now show you why H2O is H2O, and then I'm going to ask you to draw it. The first drawing and then the second drawing also. Okay, now I'm going to show you H2O. Look at that. You look at this for a while. Is this H2O everybody happy? In your video, please.
Can you repeat your question?
Is this H2O?
Yeah.
And is everybody happy?
Yeah.
You are drawing H2O, please. I'm gonna put this in the Jamboard. I'm gonna put this. I'm so sorry, it's very difficult, right? Yeah, I should have given you this already, right? This is so difficult to get. Yeah, you draw this in Jamboard, please.
Color also need to be different.
I'm so sorry, you're saying?
The color need to be different.
Oh, in your drawing, colors doesn't matter, right? The model has colors, but your drawing does not have color. Your drawing, they will pay attention to how they share electron. That's the first drawing. The first drawing is the electronic drawing. I mean, fancy name for how do they share the electron so that they become happy. That's the role of the molecular work. First drawing. Now, please draw your H2O. Draw this kind of thing on the Jamboard. I've given you the drawing somewhere. Okay. Now, you are not drawing H2O, I am very certain. Right? Very certain. First of all, look at the, I'm just going to screenshot everything. Right? Okay, just a minute. I strongly wish you have that. Oh, I strongly wish you have the model right now, right? Okay, I'm going to put O2. And I'm going to put this one in. Good. Now, what you're drawing doesn't look like H2O at all. It looks like 3 O's. Now, is it even possible for 3 O's to combine? Is it even possible?
Mm,
Is it possible for the center O to hold four things? Basically, you're saying that the center O, this guy has four hands. Is that even possible?
no.
No. So cancel this. Now you know why it's not possible. That means the world of chemistry, the world of molecule, is not a random one. What can and cannot be done does have a certain sense and rule to it. And I hope you understand why O3 cannot happen. The oxygen do not have enough hands anyway, so to speak. Now, I'm asking you to draw H2O, which looks like this. Not three O's anyway. So please draw your H2O.
Like draw, like copy from your screenshot.
Nothing copy. I don't know. What do you understand, lah? Right? What do you understand? Here's H2O. Yeah, you can copy it from the screenshot, but the screenshot does represent something, right? So draw something lah. Okay. Anyway, I have already screenshot it, so you don't see, you need to see my video, right?
I'm not sure how to draw it.
All right. So let me put it another way lah. Let me give you two options. Okay. H2O is the chemistry formula most people memorize. Well, be careful. You have the tendency to memorize without understanding, right? Yeah, then this will cause a lot of trouble down the road. We are trying to understand here. I'm not asking you to memorize in any way, right? You can memorize near exam if you feel like it, right? Right now, I am not asking you to memorize anything at all. So my question is, to help you understand, do I draw it as the first one, or the second one, or maybe both wrong, or maybe both correct? What do you think?
Uh, the third picture.
Which one? Sorry, which one?
We can repeat your question again.
Which one is correct? Indicate in Jamboard which one is the drawing for H2O. Is it this one or is it that one? Are you seeing what I'm drawing here? Or is your iPad lagging again?
I think my Jamboard got it's not loading. Oh,
Yeah, very, very, very frustrating. Okay. Which one? Right. Now, the first one is wrong. The second one is correct. You're right, it is correct. It is according to the model I show you. Right? This one. The H has one hand. I'm going to draw in the model. Sorry, the H has one hand, right? There you go. The O has two hands. The H has one hand, right? The H, I'm so sorry. The H has one hand. I'm so sorry. I need to restart my Jamboard. Okay, so now I'm going to try to show you why the first one is wrong. There, I attach the H with the H. You see the video, correct? I attach the H with the other H, and then I'm left with the Ola. According to that first drawing, I'm supposed to attach it to the O like that, correct? Oh, I'm sorry. I'm doing it the other way. Now, can I do that? Can I do that? Can I somehow do that?
No.
And so the first drawing is wrong. That's simple. The second drawing is correct. It represents how they actually bond. H actually bond to O, and the O bonds to another H, and that's what they are going to test you in that sense. Some people memorize that. Very confusing. Please try to understand the fact that the first one simply cannot happen. The second one can happen. If you try and mix and match, there is no other way around it. Next time, I'll give you the model, okay, so that you can play around. Am I making some sense right now?
Yeah.
Okay, now again, in your iPad, I'm drawing something. If you don't see, then please tell. Okay, got it. Okay, so H, O, overlap H. One from H, and then here's from O, here's from O, and then here's from H. Okay, that wasn't so good. Now that's the electronic drawing that they want. Like that. Now, am I making any sense, Kirana?
Yeah.
All right. So you have covered a very simple example of what they call a covalent bond. This is your covalent bond. This is where I share with you one electron, I share with you another electron, everybody ends up being happy. The relationship is sharing. The other word for covalent bond is sharing. I will call them the sharing bond, the sharing relationship, because that's the nature of the relationship. They do share things. When they share things, they do become happy, right? It is represented by no free hands. Okay?
Yeah.
So far, any question?
No.
Right. Now, I am going to take a picture of, in the next page, I'm going to take a picture of N. I'm trying my best to do it here. I'm trying my best. My very, very best. There you go. Okay. Now, you gotta help me help yourself. I have finished taking picture of this guy. I declare this blue guy to be nitrogen. And of course, the orange guy is still hydrogen. That will never change. Kind of easy to memorize if you want to. Hydrogen is always the orange guy with one hand. Nitrogen is the dark blue guy, or in this case, purple, with the three hands. All right. Now, I challenge you to figure out or draw or whatever, which one exists. NH, which means N1H1 basically, or NH2, which basically means N1H2, or NH3, N1H3, or N1H4. I give you 4 options. Maybe all of them exist, maybe one of them exists, maybe none of them exists. Which one exists, you think? Jamboard page 2, yeah? Okay, there you go. If you don't see anything, please go in and go out.
Okay, the nitrogen is 4 hand, right?
Three. In the
Oh,
drawing,
3.
I show you 3, and definitely that's the 3 one. Only 3. Only 3.
Okay.
Only 3. Right. So again, the question is, who exists, right? Can you figure it out? All right, and H3 exists. Just to confirm, the rest exists or don't know or what?
The H4, I don't know, but the rest, I think. Wait, actually,
You think? What do you think?
I don't know.
All right. Now back to the video. We're going to talk. You're going to say, you're going to see for yourself, Uncle. You're going to see for yourself whether it exists or not. Well, using the model, so to speak, right? Using the model. I'm gonna. Okay. So I'll start with 1N and 1H, right? Okay, there you go. Okay, got it. Okay, there you go. You see that? Obviously, the H is happy. Correct or not? Obviously. Correct? Only one hand, and the hand is, full, sharing. This is sharing, and he's very satisfied. Is the N happy? Is the N
No.
happy? No, simple. N1H1 does not exist. This will not happen. This does not happen. This is not a temp. Okay, there's no agreement here. Like, okay, hey, bro, H say to N. I'm happy in this arrangement. Can you stay unhappy for me, for my sake? No, the answer is no. No, it doesn't happen. It doesn't happen. Either all parties are happy or this shall not happen. That's just the rule in the molecular world. Fair? Understand, yeah?
Yeah.
Okay. So NH1 or N1H1 does not happen. Now, how about NH2? There you go. Clearly, the second H is also happy. See? Also happy. How about the N? Is it happy or not?
No, not happy.
In the molecular world, you cannot say H, H cannot say to N, you know what, there are two H's now dependent on you. Hey, why don't we be happy even though you are just 1/3 unhappy, just 1/3 what N, or just 1/3. It doesn't happen that way. Very difficult to explain using this model, but I can guarantee you that NH2 does not happen at all. Okay, now NH3. You have chosen NH3, and of course you're correct. Good job, right? Okay, NH3 of course exists. Let's talk about the last one. NH4 exists or not? I'm going to take another H. There you go. Okay. Does NH4 exist?
No.
Check it out. No, because there's no more hand. Keeping it simple. I'm already happy, says N. You shall not exist, NH4. Okay. Now, I will explain something next chapter. I'll call this next chapter. Next chapter, you will see things like NH4 plus. I'm sorry. NH4 plus, which is totally different. This is different from NH4. NH4 plus do exist, and we are not going to talk about it in this chapter. Let's keep it simple for now in Jamboard. Clear so far? I'm trying to prevent misunderstanding. Maybe your teacher already mentioned NH4 plus. The plus makes the whole difference. And we are not going to discuss it this chapter. In this chapter, and forever, NH4 shall never exist. It cannot happen. The rules are clear. Everybody should be happy or none at all. This does not happen. Okay, no room already. Bye-bye. NH3 shall exist, no NH, no NH2, no NH4. NH4 plus is a different matter, a matter to be discussed next time. So far, so good?
Yeah.
So right now, Kirana, I strongly wish I could give you all this, okay, and you shall have them. Okay, now, I'm going to ask you about two ends. Okay. Oh, by the way, you shall have the habit of drawing them. Remember, there are two drawing, the line drawing for Sec 4 The line drawing looks a lot like the model, so that's easy. I want you to draw the electronic drawing, the one that contains electron. Could you please draw your NH3, please? Your NH3 looks like this. I'm just going to take a picture of it.
NH3.
Yeah, which you determine has exists, correct? Yes, determine that
Yeah.
NH3 exists, correct? Right? So you're going to draw the fancy word is electronic structure, how they share the electron. Now, please draw them. That is just like the previous page where I draw all the circles and overlapping electrons. That's what they mean. They want you to draw those things.
Or the electronic structure of NH.
3, not NH. NH3. NH doesn't exist. NH2 doesn't exist, right? NH3. So draw the electrons, how they overlap, so to speak.
Is it
Tell me
like
when you're
that?
done. Now, this is wrong, and please don't erase. I want you to compare with my drawing and think carefully what it means. Yeah. Okay. What is important is not that you're wrong, right? What is important that you understand, right? And H, H, H. I'll start like that. First of all, I'll start like this, and then N has its own circle, so to speak. H has its own circle, and it overlaps N, representing a relationship, right? And then I intentionally draw inside the overlap the ones from hydrogen and the ones from nitrogen. There. This is basically the same thing as like that. Please look at the model, my stick drawing, and my overlap circle electronic drawing thingy. This needs to make some sense. If it doesn't make sense, please ask me.
Wait, why got the X again?
Okay, one more time. The X and the dot are both electrons. One more time. The X are electrons. The dots are also electrons. I'm just drawing them X and dot just to represent that they come from different sources. They are still both electrons. Understand me? You'll see triangles, you see squares also. You'll see teacher do that. They are all electrons. They are he's just trying to represent the electron from different sources. So I say the X comes from the hydrogen. The X comes from the hydrogen, the electron. The dot comes from nitrogen. Can you reverse that? You can, by the way. There is nothing wrong with that. But your teacher will demand you to draw using a different symbol to represent coming from different sources. Ask more, please, if you don't understand.
No.
All right. So one more time, to reveal to you, look at the video. There's the electron from the nitrogen. And there's the electron from the hydrogen. There, the hand. The hand represents the electron. Two hands sharing. This is what the overlap is representing, what the stick is representing. Make sense? The most important thing in all this that everybody is always happy. Everybody is always happy. Everybody is always happy. O2. NH3, everybody is always happy. H2, everybody is always happy. That is the most important rule that you're learning right now. In the molecular world, everybody needs to be happy. If somebody is not happy, it shall not. Clear ya? Can ya? Yeah. Don't try to memorize too much lah. It's one. Now I'm gonna give you a challenge. Can two nitrogens make everybody happy? Right. So I'm gonna just put here a nitrogen for you. That's one nitrogen. That's two. I'm sorry. Two nitrogen. Okay, I'll give you as many nitrogen as you like. So now there are 4 hydrogens. Okay, so 4 is just a random number. My question is, if you only have nitrogen, can they make themselves happy? And in what way? If I have more than 1 nitrogen and nothing else. You understand my question?
So only if you have nitrogen.
Only nitrogen, but limited, unlimited lah. 1, 2, 3, 4, 5. But your job is to find a configuration. Fancy word, configuration, you know. How to arrange nitrogen only in a way that makes everybody happy. What's the arrangement here? That's a challenge. So imagine you have all these things in your hand, right? What are you going to do? How shall they relate, so to speak? I'll give you 1 minute. Think about it. Okay, I'm writing in the Jamboard here. You have any idea, Kirana?
I thought if you still connect, then it's still all unhappy.
Let me show you something. You tell me whether it's happy or not. This is not memorizing. I want you to judge for yourself whether what I'm showing to you is happy or not happy. Understand, yeah?
Happy.
Just to confirm, these 2 are nitrogen. How do you know? Beside the color. Remember, I told you that, molecules don't have color one. You should think more of the hand. How do you know that what I'm holding here are nitrogens? How do you know?
Because got 3 hands.
Correct. That's the most important feature of nitrogen. Okay, in a sharing type of bond. There are 2 other bonds. So this one is nitrogen, not because I'm bluffing you, not because the color is the same, because obviously there are 3 hands. 3 hands here, 3 hands there. And yeah, 3 hands here. So I'm holding 2 nitrogen and I am kind of bending the bond like that. So you're sharing, whatever. Tell me, according to your judgment, is this happier?
Yeah.
And therefore, I screenshot for you first. Okay, to replace the model, right? So once you have the model, you won't need the screenshot anymore, right? So to your surprise or not, I don't know, but correct. N2 is the answer, and that's enough. Nitrogen
Wait, do you
2
write something in the
is
Jamboard?
very happy. Yes, I did.
Oh, okay.
Correct. So to our surprise or not, N2 is what makes everybody happy. Everybody should just form N2, 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 N2. It will be enough to make everybody happy. And there is no other, as far as I can tell, there is no other N in existence. It's N2. This is what you call the nitrogen gas. Yeah, the one that is surrounding us right now, nitrogen gas. That thing, N2. And now you know why it is N2. Because, you know, 3 bonds to each other. Okay. I'm going to show you the drawing. The drawing here is very rare because it's very rare to share 3 things. Very rare one. Okay. So I'm just going to show to you just to make sure you can draw the three lines or and okay, going to look very crowded. Okay. You're going to, oh, this is not going to be big enough, right? So 3 crosses here and then 3 dots here. That's how you draw it. That's your N2. It's not N3, it's not N. Any question?
No.
All right. So now let me challenge you. Okay, the next page. If you can do all this correct, I think you kind of understand, right? CO2. CO2. I'm showing you the C one more time. This is so difficult to show, right? That's why you have the model. This is so difficult to show 4 hands. There you go. I think I show 4 hands, right?
Mm.
Now, you have memorized CO2 for a long time, right? CO2 is something that exists, and by implication, there is no CO3 by implication. There is no CO4 by implication. Okay. The question is why CO2? That is the question to answer in this chapter. If you learn chemistry, you have to understand why the molecules only form CO2. What's going on? Why is it like that? So I give you C and I give you O also. I don't have O, I'm going to give you O, right? Should give you O. Yeah, I'm giving you 2 O's, right? Okay. So my question to you is, can you imagine how they relate to each other? Why is CO2 the thing that exists? Okay, draw something because right now you don't have the model. I certainly wish you can have the model.
Or like the previous Jamboard.
Yeah, draw something to show that CO2 makes everybody happy. Right? How? How does that work? There's an O there, there's another O there. Okay, okay. There are 3 O's there. Not sure what's going on. Because you know it's CO2, right? You know there's CO2 there. I mean, the answer key is given to you already. It's 1C and O2. Okay, you can draw more if you want for experimental purpose, but be careful there. Right? You're putting the C in the middle of the 2O. Okay, I'm sensing some arrangement here, good. But you gotta draw the electrons to show that, everybody's happy. Okay, I'm already seeing some arrangement from from your drawing. Good. You're saying that the arrangement may not be OOC. That's what you're saying, basically, right? Maybe not like that. Maybe not like that. You're saying that the arrangement is OCO, something like that. Okay. Well, draw the electrons to confirm that. Okay. Tell me when you're done.
I'm done.
Okay. Now let me show you something. First of all, please confirm that it is a C and an O, and then confirm that everybody's happy. Because again, that's the most important thing, right? Everybody must be happy. Okay, showing you something. Just confirm that this is a C and this is two O's. How do you know beside the color?
C got 4 hands. O got 2 hands.
Always and always. So 4 and then O the 2 hands. So not the color, but the hands are convincing you. Now, is this arrangement everybody happy?
Yeah.
Because you see no free hand. Simple, right? Now, this arrangement, is it like what you draw on paper on Jamboard just now?
A bit.
Quite a lot. Quite a lot. I feel that you are understanding something. That's what I feel. I feel that you don't memorize. I mean, why do I guess that? You have never seen this before, what? Have you ever seen this before? Is this something you recall from memory? The thing that you're drawing?
No.
Is it? Is this something you've seen before? The one I'm
No.
holding in my hand? Then I feel that you understand something. Maybe you're lucky, but I feel that you understand something. Just to confirm that you're correct, how do we know? Here is the 2 x's, right? Let's pretend that x comes from the C, right? 2 x's, and then the dots are here, right? The 2 dots are here, correct? And that is exactly what you draw here, right? See? On the top, 4 electrons are being shared, 2 from C, 2 from O. On the bottom, 4 are being shared, 2 from C and 2 from O. Correct? I feel that you're drawing something that will make the molecule happy. I feel that you understand how to make C and O happy. That's what we're learning. Okay?
Yeah.
Okay? Clear, yeah? This is your CO2. Let me give you your final test, and then we'll call this part of the chapter quite okay already. Because once you have the model, anything your teacher throw at you should be okay, right? How's the relationship between C? Okay, now this is open-ended, yeah? Open-ended. I'm giving you a C and I'm giving you a H, right? More precisely, I'm giving you as many C and as many H as you want. The point is you decide what kind of configuration and draw it. Do you understand? Go and draw as many C or as many H. Just make sure you make all of them happy. In the Jamboard page, it's the same page. Okay? If you don't see anything, go in and go. Okay, you have decided upon something. All right, you're overlapping it. Looks good to me. Okay, tell me when you're done, but
And
okay. Now, this is the electronic configuration, right? Fancy word, right? Electronic configuration simply means how does the electron get shared? Okay, you have drawn that. The shortcut in Sec4 will look like this. And then right now, we will call this CH4 as a formal declaration that in the relationship, 1C, 4 H's. All right, so far so good. This is your answer lah. Okay.
yeah,
Now let's look at the video lah, right? Okay. 1, the hydrogen is happy, the C is not. 2, I really wish that you're doing this right now. Okay. Then you'll gain some satisfaction knowing that you're correct. Okay. Is this C and H, just to confirm?
yeah,
Are they all happy?
yeah,
Is this what you have drawn?
yes,
I think so too. I'll take a picture of that. All right. All right. Now, Kirana, before we move on to the harder part, okay, this sounds easy because you understand, but believe me, this is so basic. People memorize instead of understand. Just bad move. Okay, because it's easy to memorize. Oh, CH4, memorize lah, you know. Then they get confused with NH3. They get confused with NH4 plus. It's a very bad move to memorize because it's very confusing and you don't understand why. You seem to understand. Right? Now, this emphasizes a few things, Kirana. Knowing yourself, you are a visual person. And if you have something that you can hold or see, that's always preferable. Okay, this simply repeats that fact. I already know that, and I hope you know that, and I hope you will play with this model to help you with your future question. Future question will be harder than this, right? But nothing that you cannot solve. Okay. Any question before we move on to the harder part?
no,
Now, what do I have in my hand?
um, 2H2.
Yeah, you're correct. You're saying it correctly. It's not 4 H's. It's not H4. It's 2H2. H2 is the declaration of the relationship, right? 2H2, right? If I show you another one, here's another one. Yeah, I have many H's. You will call this what?
3H2.
3H2. 3H2. If I had 1000 H2, just to confirm, will there be any change in the group relationship? Will 1000 H2 looks, as in, my point is this. Here's 1 H2, right? We established that 1 H2 is a happy, a happy couple, a happy grouping. a happy arrangement. Okay, very happy. If I add another H2, frankly speaking, there is nothing nothing changes in their relationship. This is still like this. This is still like that. They are not necessarily relating to each other. They're just bumping around in my hand. Do you understand? They're just bumping around. They are not forming a real relationship. Because, frankly speaking, there is no point. That's how the molecules see it. There is no point in rearranging ourselves. Why bother? And yeah, right? Here comes another one. There's now 3, right? I mean, you bump them around, whatever. Is there any change in their, relationship? Is there any change in their relationship? If you bump them around, if you ask them to mingle, whatever. No. If I have 1,000 of them, just to confirm, if I have 1,000, will anything change in their basic relationship?
No.
So there's still 1,000 H2. And right now, the chapter will say to you something like this. This is why they are gas. Now I'm going to explain that part. This is why they are gas, because some people will memorize, oh, they are gas, but they don't know why. I'm going to show you the why using the model. The bond, I'm holding the bond in my hand, and the bond, this is the bond. The bond is extremely strong. The word bond in chemistry means something very special, and take very special as very strong. So the bond is no joke. It is very difficult to separate them. Okay, I can do it in my hand, but I need some effort. If you hold the model, you will feel it one. You will feel that it is kind of difficult to separate them. That represents reality. In reality, the bond between this H and this H are quite strong. That's why hydrogen gas exists, for example. The bond between the C and the 4 H's are strong. That's why CH4 gas exists. Now, to explain why they are gases. They are gases because there are no bonds between one H2 and the other H2. I'm using simplification here. There are no bonds. See? They are not attached. They are quite basically detached to each other. Clump them around, shake them, shake them, shake them. The result is still the same. There are no strong bonds at all between 3H2 or 1000 H2. Making sense, right? Am I making any sense?
Yeah.
That's why they are gases. That's why they are gases. Because gases are simply molecules flying around. It doesn't matter whether the center is strong. The center is incredibly strong. But in the end, these are just 1000 molecules flying around. They are not cohesive. They are not grouping each other in a large way. So they are not solid. They are not liquid. They are simply gas. One more time. Whenever there is no big grouping, only small. Only small. Only small. They are gases. Very simple. Okay?
Okay.
CO2. You know that CO2 is gas, right? You're breathing out CO2 right now.
Yeah.
Why is CO2 gas? Well, very simple, right? Very simple, right? I need to lihat. I'm doing things with the model. Okay, then. What is this? Just to confirm.
Uh,
Don't memorize. Think about it. Yes, two.
to CO2.
Correct. Two, right? Two, CO2. Strong relationship between the C and the O, very strong, right? Not easy to break. almost no relationship at all between one CO2 and the other. The conclusion is CO2 is gas. Same exact reason. Understand?
Yeah.
Understand? Imagine NH3 with another NH3. Here's another NH3. Do they have relationship? Do they have a strong one?
Oh.
So they're gas. N2. Imagine another N2. No relationship. N2 is a gas. All for the same reason. The internal relationship is strong, but between them, there is almost no relationship. Your teacher will say something like they have a weak relationship. You listen to your teacher. I only explain the essential stuff. Your teacher will explain in more detail. Yeah, you cannot skip your teacher. I know you won't. You're a good student. But basically, what I'm saying, they don't have a relationship. So N2 is a gas. Not because this is strong, this bond is strong, but between N2 and another N2, there is almost no relationship. There's only one exception, okay? There's only one exception. Who is this? Don't memorize. Think about it. Who is this?
H.
Who's the two-handed one? Correct. H2O, correct. H2O is not gas. Okay, if you boil it, it can be gas lah. Okay, it's called steam lah. But in normal temperature, it's not gas, it's liquid. Because one H2O and another H2O has a very special relationship. Some teacher teach you, some teacher don't. I will wait for a while. I won't teach you the special relationship. There is a special relationship between one H2 and another H2. At this point, I'll tell you something. I'm very confused why it seems that most teachers don't explain this. Because H2O is the most important thing in our life. And yet they don't explain the special relationship that exists between H2 and H2. It affects all the chemistry anyway, but I don't understand what they don't. So I'm going to hold my tongue first. I'm just going to tell you, between H2O, there exists a special relationship which all the other gases don't have. CO2 with a CO2 do not have that special relationship. Do not. H2 and H2 do not have that special relationship. CH4 and another CH4 do not have that. Most things don't. H2 is an exception and a very important exception. And I'm just going to say that for a while. That's the exception. I'm going to explain it when the time comes. That exception explains why H2O is not gas. It's a liquid. Whenever there's a break in the rule, right, a break in the trend, the break in the normal pattern, there must be a story behind it. And indeed, there is a story. But again, I'm not explaining it right now. Any questions so far?
No.
So, most covalent bonds are gases. Who is this?
Oxygen. O2.
Correct, O2. From now on, you shall call it O2. Why? You're not a combined chemistry student. Combined chemistry student, they treat them like they're not very smart. Apologies to say that. Yeah, but most combined chemistry students that I met are smart enough to know many things. But they treat them as if they don't even understand O2. You're a pure chemistry student, they will definitely not treat you like that. But my point is, even my combined chemistry student understand why O2 is O2. So you, a pure chemistry student, should now say it's not oxygen, it's O2. From now on, O2 holds a special meaning to you. And yeah? One O2 and the other O2 don't have a special relationship, don't have a bond. O2 is gas. You know, everything is like that one. Most of the things that we talk about are like that. And yeah? So the first exception I show you is H2O, and I don't even explain why. So a bit confusing. I'm holding you in tension there. That's on purpose. The second thing I'm going to show you is carbon. The carbon is rather special. This is so difficult. I'm sorry. I cannot show you why carbon is. I cannot show you why carbon. Can I show you? Can I show that why carbon is solid? I can't show you why carbon is solid without giving you the model. It's so difficult to explain, right? Okay, I'm gonna try. Okay, here's carbon, four-handed, correct? Here's carbon.
Yeah.
Okay, four-handed. You have seen carbon in CH4, which will form gases because CH4 and CH4 have no special relationship. You have seen this in CO2. CO2 and CO2 does not form any special relationship. Now, in page 3, I'm trying to show you the last thing today, I think, YC, which is a coal. You know, your barbecue coal? You have seen a barbecue coal, it's black. And it is solid. Now, why would carbon, pure carbon, be solid? I am trying to explain that right now using the model. No memorization. Okay. It's so difficult to do if you are not holding it. But Kirana, you seem to be able to imagine it well, so give it a try. Okay, just for you, because today it's just you. The other guy is doing mother tongue O level. Can I do I can do this one. I can do this one. Right. Okay. Now, Kirana, just to confirm that attaching the pipes doesn't make the carbon happy. Do you understand why?
Cause doesn't have
Usually at
another.
the end of the pipe, there should be another one. Yeah? There should be another one. So
Yeah.
attaching the pipe doesn't mean that he's happy. In fact, this is emphasizing that he is really unhappy. Clear, yeah? So I'm just attaching the pipe and hopefully something comes, you know. And since in our world right now, we're talking about barbecue coal, there's only other carbons. There's only other carbons. Right? Okay, there. This part is now happy. Obviously, the other part is not. Okay, just saying. Obviously, the other part is not, but I'm going to continue. Okay, so obviously, this tree is now happy, but the rest is obviously not. But I'm going to continue nevertheless, right? A minute. Yeah, this is going to be very difficult to do, show you without, but I'll try my best. Okay, right. I'm now forming some sort of I don't know, a web thingy, right? Correct? I'm now trying my best to satisfy everybody and I'm not being successful right now. Okay, not yet, at least not yet. Okay, I think I'm almost done. Almost done. Not yet, not yet. I'm connecting many things. And again, I'm not successfully making people happy. Not yet. Okay. Can you see that? I'm connecting stuff, and obviously, I'm not successful at making this happy, this happy, this happy. Obviously not, correct?
Yeah.
Okay, not yet, yeah? Okay, but I will soon connect this, and then we'll talk. Okay, so connect is so difficult. Oh my goodness, it's just so difficult to show, right? But bear with me, because this is what you need to know. Right, okay, getting more solid. Getting more solid. That's my point here. On here. I'm getting carbon to be more and more solid. Almost there. Almost there. Right. Now, currently, I have connected, let's count for a while. There is a 1, 2, 3, 4 there. Can you see that? 1, 2, 3, 4 on
Yeah.
top lah. Okay? 4. And then at the bottom, I have connected 1, 2, 3, 4, 5, 6 lah. At the bottom. 6 so far, 4 on top, 6 at the bottom for a total of 10. So far, so good?
Yeah.
It should be obvious for you right now. The more I add, I will add another unhappy guy. So for this to be satisfied, this has to continue, 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 continue. Continue, 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 continue. Until where? Until forever. Does that make sense or not?
Yeah.
In order for everybody to be satisfied, it has to be continue forever. And now you see why this is solid. This is not solid. They are not strongly bound to each other. But this, the bond continue forever. So this is gas. This is solid. Because it continues forever. That's my point. Do you understand what I'm saying?
Yeah.
So one more time. I'm going to attempt to draw this. Thankfully, they never ask you to draw one. Well, yeah, they never. Without example, never. In exam, never. Maybe in practices, yes. But I'm trying to make a point. Take a picture, so complicated. I strongly wish I can give you this right now. 1C, forehand, connected to 3C. Also, four-handed, so complicated to draw, right? Forehand, right? And then C, 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 and then connect another C, connect another C, connect another C, and then so on and so forth. The more I draw, the more hands I have to satisfy. That is the point. One more time. That is the point. This is the proof why this is solid. Now, they call this in a very specific name. They call this gigantic covalent. The word gigantic to represent that it is never ending. This is just a small one. And the giganticness is the reason why coal is solid. Very different from CO2. CO2 is like that. Here's another CO2. This is not gigantic, correct? Not gigantic covalent. Covalent means sharing, remember, a very special bond. So not gigantic, simple lah. Simple covalent, which is, it is a gas. With one exception, H2O. So one more time, all the simple covalent molecules are usually gas because they are not gigantic, with one exception. This one, carbon, is not an exception. It is because it is gigantic, then, so to speak, it is solid. Okay, any questions so far?
No.
Right, I'm going to close there. And sorry, I'm not going to close there. I'm going to mention two more bonds. So there are only 3 types of bond. Some people call gigantic and simple covalent 2 different bonds. I'll call them the same because they are still based on sharing. So there are 2 other types of bond. I'm just going to mention them so that you know what happened when your teacher is teaching, right? So I'm just going to draw briefly in page 5. Metallic bond, ionic bond. And let me state, there is no more bond in chemistry. There's only covalent, either simple gas or gigantic solid, just now, metallic bond, and then ionic bond. Okay, I'll show you the representation of metallic bond. Look at that. This is a representation of metallic bond. It's totally different from covalent bond because they do act and behave differently, and you learn them together. Because once you learn all the 3 bonds, you understand most things in chemistry. Theoretically, if you memorize, then of course we don't understand. Now, watch this metallic bond for a while. Watch me for a while. I'm going to give you this also. I can squeeze it. You see it? I can squeeze it and it does not break. Do you understand? I can squeeze it and it doesn't break. Okay. For a gas, there is nothing to squeeze. Just saying, Ken, for a gas, there's nothing to squeeze. You're just flying around. For a solid, remember the J covalent. If I'm strong enough, I can squeeze and break this. I'm going to try. I'm going to squeeze and break. See, it's breaking now. Understand?
Yeah.
This one, squeezing and breaking. Okay. A coal, you can crush with your hand. Just saying. Okay. Even though it's solid, you can crush it. This is a metallic bond. A metallic bond represents metals. The way you understand metal, like your chair is metal, maybe your pen is metal. If I squeeze or crush metal, like aluminum foil can be squeezed, aluminum can be squeezed, but they are a bit hard to break. You can, so to speak, deform them, but they don't. Am I making any sense so far?
Yeah.
So this relationship behaves differently from this relationship, even though this is solid, this is also solid. I mean, look at that. How can this be gas? This goes on forever. Do you understand? It goes on forever one. Okay, you have more chocolate. See, you get it goes more and more forever also. Metals are also gigantic, gigantic covalent, gigantic metallic. Do you know why they never use the word gigantic in front of metallic?
No.
Because all metallic bonds are gigantic. So now let me show you that. All metallic bonds are gigantic. All ionic bonds are gigantic. But they never say because it's all. So the word metallic bond implies that it's gigantic, implies that it is solid. Same thing with ionic bonds. They are solid because they are all gigantic. The covalent bond is either gas or sometimes solid. If they are gigantic, solid, same reason. If they're not gigantic, then they are gases. Am I confusing you?
No.
I'm taking this as a picture so that, oh, that's a metallic bond. It's so different from a covalent bond. That's the impression I want to give you so that when your teacher show you something, you understand why they look different. Ionic bond, we don't have time. Now it's 6 o'clock, right? We don't have time. I guarantee you, when your teacher draw ionic bond, they will also appear different from the covalent bond. 3 different bonds. Tell me one more time. Kirana, what's their formal name?
For what? Covalent.
Covalent bond is this one. Simple covalent, gigantic covalent. Can? This goes on forever. This one does not go on forever. Can? Who is this? A representation of?
Where are you writing? Oh.
No, video. Who is this?
Ionic.
A representation of? No, this one metallic bond. Because I've never shown you ionic one. This one you imagine metallic because if you hold it, even the balls are made of metal, so kind of reminds you they are magnets, just kind of reminds you that this is a metallic bond, squeezable but not breakable. Okay, that's a metallic bond. The ionic bond, I haven't shown you any example. I haven't shown you any drawing. There is a possibility that your teacher start with the ionic bond. I don't know. Your teacher will either start with covalent or ionic. That's their favorite. Okay. Just note that they will be different. They behave differently, and the chapter bond kind of demands you to know the differences of behavior between them. Okay. So I've covered for you the covalent one. Listen to your teacher on ionic and metallic, and we'll talk further.
Okay.
Okay, time is up for now. I hope you find this chemistry not confusing. Later on when I see you, we'll talk about AMAT. Okay?
Wait, instead of AMAT, can we talk about bio? Because I don't understand chapter 4 for bio.
Fair enough. At this point, can we say something like this? If A math get left behind, it's okay. That was the agreement from the first. Remember that?
Mm.
Would that be okay? Will that feel that bad, Kirana?
No.
Right now, your A math is good, but you're saying that you don't mind letting A math be behind as long as your E math, chemistry, and bio are good. That's the priority. Is that what
Yeah.
you're saying?
Yeah.
I don't mind also. I don't mind. Okay. I don't. Okay. Whatever you want. Your priority, you decide. As long as it's clear, I don't mind. I'll see you later with bio. Okay?
Okay.